Okay, guys, so we do have notes today, so I'm going to do that now. You were supposed to pick up a handout in the front. If you can do that now, go ahead and do that, please. So I need you to reset a little bit. I know maybe turn off the quiz. That's so quiet for such a long time. Yeah, so if you need to get up for a little bit, or you need to stretch, or if you just kind of detach from your devices just a little bit, let's go and do that so you can focus on the notes. As we are going to start a brand new topic. So a couple of reminders. Everything on the Delta Math. Today is the last day of Delta Math. Like it or love it, I don't know. But today is the last day of doing Delta Math stuff. It will shut down today. We are back on syllabus, so everything's going kind of back to normal, the way that it was. Tests will be on Google Forms, et cetera, et cetera. So like it or love it, that's kind of where we're going, or hate it. What else? Grid protection will come out soon with that stuff. But anyhow, let's go ahead and get started. These notes can be found. You guys, you can't see the screen, let me know. These notes can be found in those of you at home. There is a paper copy. If you want to print it out, you can. If you don't, paper, journal, composition notebook should suffice. There are a couple of things that I am going to ask that you write down. Formulas, things like that, that I want you to be using, so on and so forth. The thing that we're going to focus on today is mainly the Pythagorean Theorem. We've done that already. So I'm not going to get too detailed, but I will still teach it, you know, because you are going to be tested over it. I'll try to emphasize the things that you need to know for your exam when it does come around. But anyhow, so Pythagorean Theorem, you guys know it, the a squared plus b squared is equal to c squared. You've done it before. I do want you to write this down though, because this is the formula that I want you to be using. So real quick before I start, your hypotenuse is the side that's longest, or it's opposite the right angle. So AB would be your hypotenuse in this picture. And then A and B represent your legs. And so instead of doing a squared plus b squared is equal to c squared, I want you to use this formula. H is equal to, this is if you're looking for the hypotenuse. So this one you do need to write down because it's not on your paper, because this is what I'm going to be using. H is equal to leg 1 squared plus leg 2 squared. These little numbers down here, if you'll notice the 1 and the 2 down there, that's not like a multiplier or anything like that. That just means leg 1 and leg 2. It doesn't matter which one. Like, what is it, those twins from 21 and 22? E1 and E2? Wait, what is it? E1 and E2. Oh, thing 1 and E2. Like, it doesn't, well, I guess it does matter who's who, but this is just, like, it is horrible math, terrible analogies. But your legs, it doesn't matter which is leg 1, which is leg 2. Now, if you're looking for your leg, that's completely different. Your leg, you're going to subtract. So what can I fit? I'm going to put it right here. So if you're looking for one of your legs, you're going to do the square root of hypotenuse squared minus the other leg squared. So the only difference is that if you're looking for one of your legs, you're going to subtract from the hypotenuse squared and take the square root, so on and so on. One of the only differences in this topic is going to be that you're going to have to sometimes simplify radicals. Just like you did on the quiz today, you're going to have to do that. So just kind of have these formulas. That's how I'm going to do the notes, so you're not confused. Just kind of know that. This is the Pythagorean Theorem. The converse says that if you know 3 sides of a triangle and it passes the test of the Pythagorean Theorem, then it has to be a right triangle. If it doesn't pass the test, it's not a right triangle. So we'll do some problems like that. So like when you look at this problem right here, before I start though, Pythagorean triples. Do you guys remember when I talked about the 3, 4, 5 triangle? A little bit? No? Yes? Maybe not. It's okay if y'all didn't. But a 3, 4, 5 triangle, so like if I have a right triangle, and this is 3, this is 4, and this is 5. Right, and I have another triangle that is bigger. This is 10, this is 8. What would X be? If I'm using the 3, 4, 5 template, just say it's a double, right? So this works. Just because those numbers are consecutive doesn't mean that 5, 6, 7 work. It's just 3, 4, 5 works. It's nice to know the 3, 4, 5. So Pythagorean triple means it's 3 numbers such that they're all whole numbers that make a right triangle. So these are some triples. I'm going to be honest with you guys. I don't have any of these other ones memorized. I kind of maybe sometimes recognize them, but I don't know them. So I'm not going to ask you to memorize them. You're not going to be quizzed over it, but you do have to know what a triple is. A Pythagorean triple is any 3 numbers that would be that make a right triangle. They're whole numbers. So there's an infinite number of these. So the only one I would ask that you kind of see and recognize would be the easiest one, which is a 3, 4, 5. Any multiple of this one works. So like a 30, 40, 50 is a 3, 4, 5. That works. So just kind of know that those are there. So that's Pythagorean triple. So and so on. From there, there's an infinite number of those. This one here, example 1, is just asking find the value of X. So I'm going to use that formula. So I'm going to use the formula that we introduced here and start up your notes. If I'm looking for the hypotenuse, we're going to use H is equal to the square root of leg 1 squared plus leg 2 squared. And you just plug it in. So this would be 6 squared plus 2 squared. Remember, these 2 numbers here represent your legs. So then if I do 6 squared, that would be 36. 2 squared is 4, which gives you the square root of 40. Now, if the question says, answer your question in simplest radical form, then you have to do what you did during the quiz. You have to see, you have to simplify, you can't put like 6.2 or 6.3. You have to simplify that. So just like your quiz, you would do 4 radical 10, and so this would just be 2 radical 10. So you do have to simplify radicals.
So it'll be H equals 2 radical 10.
Say it again.
It'd be H equals 2 radical 10.
Yes. Yeah. So H is equal to 2 radical 10. Does that make sense? Can you do that? So and I'm gonna skip problems. I'm gonna be skipping around. We're not gonna do this. Omit means we're not gonna do it. You're not being tested over this. It's not in your quiz. It's not in your test. So if I skip it, that's why we skip it. And I'll be doing that throughout the next. So on this one here, if you look at this triangle, it's asking for this part right there. Wrong choice of color there. No, I chose green. That, what you see there, is that a leg or a hypotenuse? What we're looking for? It would be a leg, right? So you're going to use that formula that I gave you at the start of class. So you're going to do leg is equal to the square root. Let's do leg 1. Hypotenuse. That's right. So just go ahead and just plug it in. What's your hypotenuse in this picture? 36. Your hypotenuse would be 36. I know those of you at home, that might be harder to see. That's a 36 in there. And then this one would be your leg, right? I'll call it leg 2. Just plug them in. So you just do hypotenuse, which is 36 squared, minus 26 squared. I will say this. If you look at the problem, it says round to the nearest inch, which means you don't have to simplify it. Guys, there's a lot of calculators you can use. You can use your iPhone, there's apps, there's no scientific calculator. So this one you don't have to simplify that. You can just put it in a calculator. So I'm not going to simplify this one all the way. I'm just going to type it in. The Desmos calculator, scientific calculator, is really good for stuff like this. So I'm just going to do this in a calculator. So I get about 25. Well, I'm going to put 24.90 inches. What is this to the nearest inch? Oh, so it should be 25 inches. About 25 inches. About 25.
That's fine.
That's fine. So I did want to just kind of show you that. So just kind of read the problem. Does it want it simplified radical form or the decimals? You don't have to, you can just type that in the calculator. There's a lot of apps for that. We don't have M spiders, so pretty easy. We're going to skip this one. Now, remember what I said that you can use the Pythagorean theorem to check to see if numbers make a right triangle. So right here, they're asking you, out of these three sides, does it make a right triangle? So you can test them. Out of those three numbers, which one has to be your hypotenuse? 85, the biggest one. Well, that's all that matters. This one has to be your hypotenuse, C. And then these don't really matter, which is your A and which is your B. You can just, now this one we will use the generic Pythagorean theorem. You're just going to test it. You want to see if it's a true statement. So this would be 85 squared plus, oh, my bad, that's wrong.
84.
Yeah, I meant to put an equal sign there between them. All you're going to do just to make sure that this is a true statement. I think 85 squared is 7,225. If you add those, it's also, so that's a true statement. So therefore, it is a right triangle. It proves that it's a right triangle because it's true. This satisfies, or I'm sorry, this satisfies the Pythagorean. Then it is a right. If they were not equal the same, then it's not a right triangle, it's something else. It's a scalene or something that's not a right triangle, so on and so on. So you can use it to test numbers to see if it's a scalene. Monica, did you need a pencil or anything?
Yeah.
What? You have one?
Yeah.
Okay. We're going to skip number 6. We're going to skip number 6. On that one. So is it backwards? Yeah.
You skip example 6.
Yeah, we're going to skip example 6. So we're going to stretch it out. So this problem is asking, find the missing link to all the sides forming Pythagorean triples. Pythagorean triple, all that means is they have to be whole numbers. If the answer comes out to a whole number, all three of them, it's a Pythagorean triple. I would use the Pythagorean theorem, the formula that I gave you earlier for looking for the hypotenuse, but this is a Pythagorean triple. What I want you to do is, well, I know some of you at home don't have this, but memorize these numbers. If you're at home and you don't have the notes in front of you, look at that. Go back and look at the Pythagorean triples that we saw earlier. Which of these three is the 1448?
The 8, 15, 17.
Okay, what do you guys think? You're right.
7, 24, 25.
It would be this one.
Yes.
Let me show you guys why.
That's right.
Yep. 7. This is really 7, 24. So if these are 7 and 24, what does that have to be?
86.
7, 24, 25.
Oh, that's 25.
50. I heard somebody say it.
That's 7, 24.
So I think it was 7, 24, 25. Was it? Is it?
Yes, correct.
That's correct. Now you could have used Pythagorean theorem. You could have used the formula that I gave you. You could have done squared plus 48 squared, and you would have got 50. Because all three numbers are whole numbers, it's a Pythagorean triple. Does that make sense? Okay. So I want you guys to try this one. All right. I want you to check to see. I want you to find x. You're going to use this formula because you're looking for a leg.
Oh, you that one?
Yes. I mean, if you want to use the original.
Is it a Pythagorean?
It's asking if it's a Pythagorean triple. Oh, I see what you're saying. You're looking at the other page, right? You can actually look at that page, right? If it's not on that page, it's, well, yeah, if it's not on that page, you gotta be careful. As long as it's not a multiple of those, yeah, it wouldn't, it's not a triple.
Would it have to, if it's a one multiple of one, does it have to all be the same multiple? After the last one, they
Yes.
all like two.
Yes,
So it's not like-
you're right. So what Gian was saying was he's looking at that list. There's no way this is one of those triples, a form of it. You know what I mean? Like none of those got multiplied by 2 or by 3. It doesn't fit. Now, if you solved it, I think you get like some decimal or something. You get a decimal answer. If you get a decimal, this cannot be a triple. There's no way it can be on that list. Remember, you get to use your notes on the test, so this is something that you get to use and you can check on there. Just remember that on this one right here, if you want to, I mean, you don't have to. You can do the first couple if you want. So like right here, maybe let's do this. Maybe this will help. Just maybe list a couple, so go like 6, 8, 10. That one is they're in the same family. Does that make sense? So if you don't have to do this, it's up to you if you want to. This one would be what? I'm just doubling it.
10, 24, 26.
Right, you can keep going, right? Now you can multiply something by 3. You can do 15, 36, 39, so on. You can just keep going and going and so on and so on. You can make more families. So if you did this one, this would be 16, 30, 34, 14, 48, and 50. You can continue each one of these, go down, and make more families. If it's not on there, it's not a Pythagorean triple. If it's not in that group on there, so, and that's kind of hard to see, but that's as big as I can make it. But hopefully that kind of gives you the idea on there. So you would see that those numbers would not fit or work for this one here. So this is not a Pythagorean triple. And the last thing, make a note of this right here. Maybe because you'll come back to this. So you can use, this is the last thing we're going to cover, I think. The Pythagorean theorem can be used to help you classify a triangle as obtuse, right, or acute. The key thing is that you can do a test. If c squared is greater than a squared plus b squared, it's obtuse. If it's equal to, it's right. If it's less than, it's acute. And you're just going to kind of plug in the numbers in there. And you just kind of check it. So again, just make a note of it. So how does that work? The first thing you have to do though, is you have to check to see if it makes a triangle or not. So I don't know how well you guys remember, but if I look at these 3 numbers right here, can those 3 side lengths make a triangle? Do you guys remember from?
Yes.
Yeah, they can. You guys remember? That's awesome. You don't remember?
Two small sides are greater than the large side.
That's right. So, John said is that the 2 smaller sides are greater than the 3rd side. So this would be what, 12? So then yes, it makes a triangle.
If it's right,
Now, it's right. Now we're going to use Pythagorean theorem to check to see if it's acute, obtuse, or right. That's what we're going to do next.
25 plus 30.
The key with this one though, you gotta do the C on the, well, you're gonna use that formula, that's what you put a star by. You wanna do, put the C first. Okay, so which of these 3 have to be your C? 10, so you would do 10 squared. I'm gonna leave a little bit of room, and then I'm gonna do 7 squared plus 5 squared. So 10 squared is 100, 49 plus 25. So this would be 474. So 100 is bigger, right? So go back and look at that, the bottom of the last page. Right? So we look here. So it would be an obtuse triangle because it's greater now. So this would be obtuse. Obtuse triangle.
This is actually way less complicated than I thought it'd be.
It's not, but if you have, long enough formulas, so on and so on, you kind of put it there. What about example 10? Do those make a triangle? No. So you don't even have to check. So 5 plus 8 is less than 17. That does not make a triangle, right? So it does not make, so you don't have to check.
So what would be this?
No, it would be none. You can't, it doesn't even make a triangle. So you just put does not make. You don't even have to check. And then on the last one, yeah, we're gonna skip 11. I mean, well, the only thing I want to say about 11 is, does that make a triangle? How about let's do this? Do number 11.
No,
It doesn't?
I'm sorry.
It does, right? Do number 11, it does make a triangle. So calculate, do you guys see how it makes a triangle? Anybody not see how it makes a triangle? You just add up the 3.8 and the 4.1, right? So then calculate to see if it's acute, obtuse, or right. It's acute? Okay. Yeah, it's acute because these numbers here would be greater, right? 31.25. So because this is less than, it's an acute triangle. So I would ask that you kind of just remember to have that part in it, because you can use your notes. So just save that part, put a star on it, and then go from there. This right here, guys, I would just make this into decimals. I would just make decimals with those. And then just do the same thing get up here at the top.
So to the number next to them, right? Would you just do the square root of 5 times 2?
What do you mean?
So it's
Oh,
two
yeah.
times
This is slow. Yeah, so to make these in decimal, you just do 2 times radical 5 in your calculator. Make a decimal. I was going to teach this morning, I taught how to do it by hand, but I don't think it's needed. I mean, I would just say just make them decimals. I ended up showing them in decimals anyway. So that's why I'm not going to show you. So like, for example, I would do 5 radical 2 times. This would be like 4.5. So I'm not going to do this problem, but I just want to let you know how they do it. And then you would go there and then you would just do the same thing. This one does work, by the way. I think it's a 2. Does that make sense on how to make it decimals? You will have something like this on your status. Okay. So that's pretty much it. So back to Sabbath, it's on there. So 10.1 is on the thing. So you can work on there. And that one is due Tuesday. 10.1 is due Tuesday. You're good, Audrey.
Okay, bye. Have a nice day.